let's use another example to put together our notion of the definite integral representing the area under the curve and our partitions in order to find a total antiderivative for a function. So let's say f of x has the graph shown below. Let's use our partitions and some common geometric formulas to evaluate these areas. So our first area right here, we're saying let's find the definite integral from -1 to 3 of f of x dx. Well, on our graph right here, it looks like -1 to 3 can be found right here. So let's take this region, which I'm highlighting here in yellow, and I want to find its area. Well, in this case, it looks like we're just going to take the area of a rectangular region in which we have a height of 2, and we have a width of 3, -1. Let's do that again here. -1 minus -3. Well, of course, that's a width of 2 as well. And so that area right here is going to be 4. All right. The next one tells us let's find the definite integral of -1 to 1 of f of x dx. Well, we don't know exactly what this function is going to be, but we can see that it looks like a piece of area where we have a semicircle indented into what appears to be a rectangle here from -1 to +1. Well, what should we say about this area? Well, if we're looking to take this area, I'm going to highlight, it looks like we can say that we've got the area of a rectangle. And I won't bother doing the subtraction right here. You already know that that would be that rectangle with a width of 2 and a height of 2. But we're going to subtract from it a semicircle, and it looks to be a semicircle with a radius of 1. And so we're going to take that to be pi times 1 squared. And we'll subtract that away. Well, half of that, right? Because it's a semicircle. And so our region should look like 4 minus pi over 2. Right, so that is our region number 2 right here, 4 minus pi over 2. All right, our next region over here, we want to find the interval from 1 to 3. All right, so let's go from 1 to 3 of this little area right underneath here, which I'll highlight. And you can see that it looks a little bit like we're talking about a triangle here, and a right triangle that has a base of 2, right, our length 3 minus 1, and has a height of 2. And so if we take 1/2 of the base times the height here, we're going to get our geometric formula telling us that this is an area that looks to be equal to, well, 2. And then finally, this little bitty area right down over here looks like on this interval from 3 to 5. And so if we're interested in finding this area right here, 3 to 5, we're also dealing with a triangle, which I will. And it looks like in our summation right here, when we take this sum, let's see, we have another triangle that has a base of 2, but this time a height of only -1. So we have to be careful because that falls below the x-axis. And so, of course, our area right here, this one's going to be -1. So if we think about the areas that we've got right here, look at what we're going to do. If we say let's find the interval, the definite integral from -3 to 5 of f of x dx, we're going to take the sum of 4 minus pi over 2, 2, and -1. So putting these together right here, it looks like we're going to say 4 plus 4 minus pi over 2 plus 2 plus -1. And it looks like that has got to be 8, 10, 9, 9 minus pi over 2. And so we would call this our total area under the curve.